Hey everyone, welcome to our channel. I am Siddhartha. In this video, we will be covering some essential concepts in computer science and programming that every aspiring coder should know. So whether you are just starting out or looking to brush up on your skills, this video is for you. In this video, we will look into the fascinating world of system internals, exploring the inner working of computer systems. Then we will dive into the debugging techniques essential for troubleshooting code in program like CS50. Next, we will unravel the stages of compilation and discuss the C language compiling process. Let's get started with system internals. Computer system consists of various components, including the CPU, memory, and input-output devices connected to a bus controller. Understanding these components is essential for programming and troubleshooting. CPU and memory interaction. The CPU interacts with memory to execute instructions and show data. This interaction occurs through a series of steps, including fetching, decoding, and executing the instructions. The executed commands are shown through input and output devices. The input and output devices allows users to interact with the computer. These includes keyboard, mouse, joystick, scanner, webcam, microphone, monitor, printer, speaker, headphone, projector, facilitating data exchange between users and the system. There are also another type of device which are called as storage devices. Storage devices play a crucial role in computer by providing permanent storage for data and programs, ensuring accessibility and preservation of information. Examples of storage. Okay, now what is the role of operating systems? Operating systems manage system resources and provide a user-friendly interface for interacting with the computer. There are different types of operating systems for the computer like Mac OS, Linux, Windows, Ubuntu, and etc. The operating system handle tasks such as memory management, resource management, security management, command interpretation, file management, and also input-output management. In conclusion, understanding system internal provides a foundational insight into how computers operate and encompassing the interactions between the CPU, memory, and input-output devices. This knowledge serves as a cornerstone for effective programming and troubleshooting, empowering individuals to harness the full potential of computing technology. Now, let's delve into the world of debugging in CS50. Debugging is an essential skill for programmers, allowing us to identify and fix errors in our code. Let's go to CS50. So this is my code space in CS50. I have already written two codes, hello.c and sum.c. In hello.c, I want to print hello CS50 as the output. So let's try to run the code. To run the code, first we have to type make and the name of the file without including C. After entering C, I'm getting an error that some implicitly declaring library function printf. So as a beginner, I don't know what the error is. So in order to resolve this error, we have to type help50 and I will try to run the code again. Make hello. Again, it is telling that I made some error at the end. So I will ask the help 50 again. It is telling that are you missing a semicolon at the end of line 4? Okay, okay. So after the printf statement, I forgot to add a semicolon. So let's add it. And now I will run the code. See, the file is made. We can see a file here, help, hello. Now let me run the hello.c by clicking dot slash hello and click on enter. See, I got my output as hello CS50. Now I have another code sum.c where I made the code to take two inputs and give the sum of the two numbers as the output. So let me try to run the code. Make sum. See, it is telling that some error unidentified, undeclared identifier. So I even don't know what does undeclared identifier mean. So we can see there is a CS duck debugger in the left corner. So after by clicking on it, you can ask the debugger any question regarding the code. See, I'm asking what is undeclared identifier. So the bug debugger is a very, now we got the answer that we have not declared the variable. So to fix it, we will ask again, we will ask help 50. See, it is asking for help and we can see the error that by undeclared identifier, clang means you have used a name num1 sum.c. If you mean to use num1 as a variable, make sure you declare it by specifying its type and check that variable name is spelled correctly. So here we thought num1 as a number. So num1 means number, means it is an integer. So I have to declare it by typing int num1, num2 and sum. So I will try to run the code again. And now again I got the error just like before I got for printf. So I forgot to add semicolon here. So let me add the semicolon. If you have any doubts, you can ask help 50 and it will tell you, yes, see, it is telling that at the end of line 7, I forgot to add a semicolon. So let me add the semicolon here. And now again, I will try to run the code and it is telling that again, I forgot something. So I will ask help 50. It is telling that at the end of line 10, I made a error. So see here, I forgot using ampersand here in the 10th line. We have to add an ampersand so that we can address the location for it. Or simply you can copy the code and ask the duck debugger to correct it. The duck debugger will correct the code and will give us the input. See, it is telling that when you're using a scanf, you are missing the ampersand symbol before num2. This symbol is necessary because scanf needs the address of the variable to store the input. So in line 10 before num2, we have to add an ampersand. That's it. I think our code is right. Let's try to make it. Yes. Now let's try to run it. I'm entering the first number as 5 and the in this section, we will explore the stages of compilation and the various files generated during the C compilation process. Understanding these stages is crucial for building and executing programs. So there are 4 stages. The first one is pre-processing stage. In this, it handles like directives, macros, and conditional compilation. It produces an expanded source code file ready for the compilation. This pre-processed code, that is expanded code, is sent to the compiler. The compilation stage translates the pre-processed source code into assembly code. Now, the assembly code is sent to the assembler. In assembler, the assembly code is converted into object code, that is machine code, like which consists of ones and zeros. This stage checks for syntax errors and produce the objects file. This object code is sent to the linker. The linking stage combines multiple object files and library files into a single executable file. It resolves external references and generates the final executable. The executable can be in the form of .exe or .out. It just depends upon the operating systems. Now, let us understand the compilation process in a better way by taking an example of C. Here, the source file is hello.c. We know the output for this code is hello CS50. But let us see how many files will be generated in the process of compilation. Go to terminal and type clang space hyphen save hyphen temps and space and the file which you want to compile. Hello.c. Enter. See, in left side you can see there are 5 files generated: a.out, hello bc, .i, .o.s. First step of compilation is called preprocessing. Here .i file is generated. In this file, the lines starting with the hashtag are interpreted by the preprocessor and the comments are removed from the source code. As we can see in hello.c, I gave hello CS50 in the first line, but we can see there is no such line in this hello.i. And also hashtag include stdio.h is just expanded. And we at the end of the file, we can see our code, which is of just 5 lines. And after this step, the second step is called compilation. .s file is generated. Here, the C program is verified for syntax errors. It is generated into assembly language. It's just of 37 lines. And we can see hello.cs50. This is what we want to print. It After this, assembler is used to translate the assembly instruction to object code, which is of .o file. See, we can open it using a text editor or hex editor. We even can't understand the hex language. So yeah, here hello.cs50. This one is the code we want to print it. Now, after this one, the generated object file with a standard library file and it generates the final executable file, which is .out, a.out. We can't open it, but if we can open it using a hex editor, see, this is what we get as the output. As we can see, yes, here is our output, hello CS50. In the flowchart is given here, preprocessor to compiler and then into assembly code and then into assembler, converts into a object file and then all the libraries and the object file is linked and we get a executable file.